everyone, I'm Risona Parveen, Assistant Professor of Department of Mathematics from St.Josephs College. Today,
So today let us start a new topic, that is numerical methods, or we also call it numerical analysis. So the very first topic of numerical methods or numerical analysis is errors. Now let us first move to accuracy of numbers. So there are two kind of numbers. One is exact, another one is approximate numbers. Types of error. So the first type of error which we study is inherent error or input error. Second is round off error, and third is truncation error. So inherent error. First is inherent error. So inherent error is already there in the problem statement. So when a problem is first presented to the numerical analyst, it may contain certain data or parameter. So this parameter involved can only be determined approximately, so it will give error in the initial. Like for example, if we consider, so students, can the inherent error be removed completely? No. If the error is itself in the machine, we cannot remove. However, we may minimize the error. We may always minimize the inherent error by saying next error is round off error. So this error creeps in when we approximate any number. So when we have rational numbers, say 1 by 3, say 22 by 7, or 5 by 9, or so on, so whose decimal representation involves infinite number of digits. So we are forced to take only few number of digits from the decimal expression. So the error which creeps in is called round off error. So in the round off error, basically we say that, so if we depict any rational number in decimal system, due to our limitation to take only finite number of digits, this error creeps in. So it occurs from the process of rounding of the numbers during the computations. For example, in this case, if we take 8.954266, suppose I am using this number in one question, and in another question I am using an approximation of this. So if I am using this one, then the error which will creep in is 8.954266 minus say 8.95427. So we can see that there will be an error of this. Similarly, if we round off it to 8.9543, then the error involved is almost this much. If you remember in the inherent error section, when we are rounding off and approximating the numbers because of our limitation to take the significant number of digits. Okay, students, so we may always minimize round off error. First thing is, while calculation, we can take the significant digits more. And another form is, if say we may cancel out something and put the identity which we are getting in the correct format, then also round off error may be removed. Truncation error. So in numerical method, this error creeps in when exact mathematical formulas are represented by approximation. So for example, consider this formula for sin x. So we have this exact formula for sin x, but if we truncate this formula, that is, if we chop off rest of the terms, so if we chop off all this term, that is the meaning of truncation. So if it is chopped off, it means that we are taking lesser terms. So we are approximating the exact formula, and due to this truncation error comes in. Suppose we take the
thank you everyone for listening. I hope this is helpful.